We're going to continue with functions. So looking at the functional values, so the first one, a linear relationship. So y equals 3x plus 1. So that's essentially what we already learned. The linear equations of y equals mx plus b. So this is a function, and we saw this example by looking at a graph that is a line. It never ends to the left and never ends to the right. So yes, a linear equation is a function. And we say y is a function of x. So that's looking at the second term of functional notation. F of x equals 3x plus 1. So this is not f times x. This is a function the way we read it. So function of x. And this is the same thing as y. So f of x is actually y. So look at the first example. So this means the same thing. It's just rewritten. You can interchange them. So when we look at functions, they just don't write y. They put f of x instead, but it means y. So again, f of x is not f times x. That's the main thing, the most common mistake to remember. And looking at this, the x right here, this is our x coordinate. So f of x equals y. So this is our x coordinate. And then this is our y coordinate. And these are ordered pairs. And this essentially could be written as an ordered pair. Kind of like that. Again, that f of x is actually y. It's just interchange. For functions and this type of graphing, they don't write y. So keep that in mind. All right, so let's look at the ordered pair on the third example. So ordered pair on y. So they give us the 3. So we're going to use the 3 and we're going to plug it in. So instead of x, plug in your 3. So use the equation 3 times 3 plus 1. 3 times 3 is 9 plus 1, 10. But f of x is actually your y, right? It could be interchanged. It means the same thing. So for my ordered pair, when 3 is x, what's my y? 10. So that's the ordered pair. Now, when looking at our function, it means the same thing. So if we go to write this, f of x, so f of 3, when x is 3, our y is 10. So this means the same thing as that. That is how you write an ordered pair as a function. So let's keep doing some more examples. All right, given the function, this equation, we need to find f of -2, f of 0, and f of 3. So we're going to plug them in. So f of -2, so instead of x in our equation, we're going to plug in -2 like we always do. 4 -2 squared plus 3. You always want to do your exponents first. -2 squared is +4. So 4 times 4 plus 3. 4 times 4 is 16 plus 3 is 19. So f of -2 is 19. But remember, that's really just y equals 19. So if I wanted to write this as an ordered pair, my x that we plugged in is -2, and then our y was 19. So that's a point on this function. All right, start over. But instead of x, we're going to plug in a 0 this time. So 4 times 0 squared plus 3. 0 squared is 0. 0 times 4 is 0 plus 3 is 3. So when x is 0, our y is 3. So you can write that as an ordered pair, 0, comma 3. All right, last time, start over. So f of positive 3 equals, so instead of 3, instead of our x, plug in a positive 3. So 4 times 3 squared plus 3. 3 squared is 9. 4 times 9 is 36, plus 3 is 39. So it could be written like that, or if we wanted to write it as an ordered pair, our x was 3, and 39 is the y. So all of those points are on our functional graph. All right, it's really important. So in the homeworks or other problems, you might see f of x, g of x, h of x. They all mean the same thing. But it's very important to remember that it's not f times x. It's a function of x. They're not multiplying. That is just telling you that's what the x coordinate is. All right, let's look at example number 4. Find an ordered pair using the function of 3 equals negative 7. So remember, this is my x coordinate and this is my y coordinate. So just write it as an ordered pair. Do not overthink it. So 3 comma negative 7. And example number 5, now we want to write the functional notation. And so they give us the ordered pair. So f of x equals y. So plug in my x, which is positive 1. And what is the y? 15.